Hi, I'm Vinny Gupta of the Ethereum project, and I wanted to take a crack at a new way of describing the kind of socio-cultural positioning of blockchains as a technology. I know there's been a lot of discussion about blockchains and libertarianism and their potential for kind of hyper-capitalism or this kind of hegemonic intrusion of libertarian ideals into the rest of the world. I wanted to try and break some of that down and locate blockchains as a technology inside of the history of computing in a way that I think will shed a little bit of light on what they're actually good for and how the technology is likely to evolve in the next 10 to 20 years. So long-range horizon kind of stuff. So to get that far forward, we've got to go back to the early days of computing before we had networks. So you go back to the kind of 1950s, 1960s, 1970s era of computing. Computers are these huge, mainframes, right? Warehouse-sized machines. Liquid cooling, not uncommon, floors where you have this kind of cable runs underneath the floors. The floors are elevated by 1.5 feet. Guys literally in white coats there to service the machines. That phase of computing preceded networking, the ability for machines to talk to each other, by decades. So it wasn't really until the 80s when some comes along with this idea of the network is the computer networking was understood as being an integral part of what computers were. There was a point where computers were just for computing. They weren't actually network devices. They weren't for communications. The SQL database standard goes back to about 1970, work of a guy called Cod who worked at IBM. And the database as the core of a company's operations predates that for a while. At this point, storage is not usually on magnetic disks. It's not spinning rust, as we call it. It's actually magnetic tape. And the reason that databases have all this fixed field stuff that you might have been exposed to is so that you could basically say, right, it's 461 records down that way. Each record takes 11 inches of tape. We have to go, wherever it is, 138 feet down the tape. And then you'd have very precise tape drives that could spin you forward to within 1% or 2% of that, and then you'd play forward until you hit your record. This stuff is extremely archaic. SQL also has this concept of these queries where you kind of join tables into this large multi-dimensional cube, and then you use algebra to specify a locus within the cube, and that's your query, and then the database iterates through the multi-dimensional volume to give you all the data that's inside of it. Yeah, complex. Back in the day, you could only do one join per tape drive that you had. So the number of tables that you could link together to do one of these kind of multi-dimensional queries was limited by the physical number of tape drives you had. 5 drives equal to 5-way query, so you could unify data across 5 tables. Seems kind of unthinkable now, but that's how it was. And all of those conceptual models are baked into SQL. So you come forward to the present. Generally speaking, large organizations represent the core of their reality in SQL databases. You will get a whole bunch of documents which cover things like policy, but when you actually get down to the operational level, databases of customer records, databases of tax transactions, databases of invoices, it all gets stored in these very, very rigid structures which are built on conceptual foundations that at this point go back 50 years. And those conceptual foundations affect what organizations can see in a kind of seeing like a state, sort of stacktivist kind of perspective. If it will not fit into the database scheme as it currently stands, it doesn't exist. And organizations typically have a kind of unified common operational picture, which is their databases. And then in the areas where the database can't be brought into conformity with the present working conditions, you'll typically have these little kind of guerrilla databases which grow up in things like Excel spreadsheets, where staff members will keep additional data that they cannot get into the mainframes or into the big databases because the price of rearranging the schemas is too high. And that kind of model with the database as this enormous fixed object that is at the heart of organizations and defines organizational reality is a completely dominant part of why culture works the way it does. You end up with these very, very big, heavy organizations with huge data resources, like, for example, Google, and more support resource tends to migrate to the data resource. The centralization is inherent in the technical architecture of the databases, and furthermore, databases don't play nice with each other. So inside of an organization, you will set up this extremely complicated model of reality called the database schema. And because it's so expensive to change, the database schema becomes reified. It becomes literally the dominant model of reality for the organization in the computer says no kind of model, right? The expense of changing the schemas tends to produce an enormous amount of ossification. When two organizations want to collaborate, the database schemas will typically not overlap. They'll have two different ways of parameterizing the problem. The insurer sees reality one way, the hospital sees reality another way. When the two attempt to communicate, you then get a series of what they call APIs, application programmer interfaces. And the APIs between organizations typically take the information the organization has, format it in the way that they think the other organization wants it, and then try and push it down. So it has to come all the way down the conceptual stack on one side, across the network, and then all the way up the conceptual stack on the other side. And this problem turns out to be much harder than things like machine translation because it can't be solved at a sort of syntactic level. You can't just throw statistics at that problem. You actually need some set of human beings mediating the process of downstepping the data on one side and then upstepping the data on the other. And this turns out to be really, really difficult because if the conceptual models don't actually coordinate, you wind up with these huge, huge, huge problems. And those problems are typically solved by putting glue code in the middle, which basically has a ton of additional complexity to unpack and repack the data using the assumptions of the other option. So this sounds bad and bad enough, but it's then subject to a thing called the n squared problem. So if I've got 15 organizations that want to talk to each other, we wind up with n factorial pieces of, n squared pieces of code, half n squared pieces of code, which are going to be necessary for all of these organizations to connect all the other organizations. So you wind up with 120 something bits of code, which are connecting the back ends of these organizations together. And if any one of those has a bug, your business processes stall. So you have to keep 120 bits of code in sync, because every time one of the organizations updates its operations, all the connectors have to be rechecked, and the bugs can be subtle. So you wind up introducing something like Unicode characters. They get carried from one organization through one or two other organizations whose software is modern, till eventually you hit a legacy system that breaks, and it's 2 or 3 handshakes out from where you were when you made the changes. So that problem is so intractable that there have been generation after generation of attempts to break it down. The biggest one of these in recent memory was a thing called XML EDI, which is a technological push in the 90s to try and figure out interoperability standards so that business could be done as a series of API calls between different entities to actually push data down a supply chain. So in that kind of model, I would order something from Amazon with a set of API calls to Amazon. Amazon would use the same basic technical standards to talk to its warehouses. The warehouses would use the same technical standards to talk to the suppliers, and all the tax data would be pushed out with the same technical standards, and the credit cards and all the rest of this stuff. Everybody would be using these basic same platforms. Before that, there was SOAP, which was, I think, a Microsoft-led effort along these kind of lines. Then you come up with all the sort of JSON stuff that you see these days, but you always hit the same class of fundamentally conceptual problems when you try and get two organizations who are defined by separate databases with separate schemas, because the reification of ideas into the database schema is the core function of the organization, and you can't get these things to interoperate. This defines the world as it currently operates. Huge silos in organizations with reified database schemas are unable to interoperate with each other except in extremely laborious ways, because the conceptual tax, and therefore the financial tax, of implementing the necessary connectors and software is too expensive. This is why everything is balkanized, and why it takes 74 phone calls to get your utility set up when you move into a new house, into the house, update a set of records, and then have the machines talk to each other to figure it out, because having the machines talking to each other means getting through the conceptual logjam of every organization's database representing reality in different ways, and therefore needing an almost infinite number of connectors to make the damn things work. State of play. Along comes the network computing age. So late 70s, early 80s, you get computer networking at a technical level. Some comes up with the network as the computer. The web is the first really large-scale success of this kind of network-centric model of the world. So we've moved from the computer as basically a tool for computing on data to it's mainly a tool for communication. So in the communication-centric world, we generally speaking avoid databases. So if you think of a website, there is a database inside of the website, and it's buried pretty deep. It does store the content. But when the content comes forward and is used, it's turned into documents. And generally speaking, in network-centric operations, because the conceptual mashing of databases is so hard, you have kind of document-centric computing and document-centric models. What you push and pull on the web are documents. It's fundamentally a textual medium because there's never been a convenient way of doing integrated data across the web. This is why there's such a big push behind this whole link data initiative, because it's another attempt to try and get around the backside of this terrible problem of database schema incompatibility between orgs. So in the network-centric paradigm, you're basically storing your knowledge in documents. You exchange the documents with each other. This is a very human-centric model. People are going to have to do the majority of the work on looking at those documents, or you wind up basically emailing each other XML spreadsheets and then putting them into the databases manually, and we're back at the whole kind of XML EDI mess. Nonsense. So the clash between network and database cultures carries through the technology. Databases, machines pushing data to machines, networks, humans pushing data to humans using documents as a format. Where these two things collide, typically what you wind up doing is having a database-based organization that publishes the data as a set of documents. That tends to be a one-way process. It's very hard to get knowledge and information into these organizations because everybody protects a database as if it is the crown jewels, because if the database is damaged, the organization ceases to exist. There is no Visa without Visa's databases. Now, along comes the blockchain. The blockchain is a database that works like a network. So the database, had we designed it after the network was invented, would have a property where anybody who was on the network or in the network could read or write information from the database in a shared way, and you would have enough commonality in how the databases were deployed that you could do communication through databases to other people. So rather than having monolithic database surrounded by protective rings of organization, you wind up with a network database which enables structured communication in terms of the exchange of content as data rather than as documents. So data rather than document, but network rather than centralized. And the reason that this is possible on blockchains is because everybody's sharing the same database. And at that point, the standardization is imposed when you choose to read or write to the database in a format you expect other people to be able to read. So rather than having these reified schemas where every organization has a different model of reality, you have a necessarily shared schema which everybody is simultaneously using because it's on the blockchain and everybody's looking at the blockchain. So the standardization is in the same kind of manner as for things like TCP/IP, where condition of network participation is you're going to have this database and it's going to be spoken to in the language that it understands, in the schemas that it understands. What does this buy us? So right now, organizational collaboration is basically stalled because the databases can't talk to each other. If you've got organizations that are sharing a blockchain, then the potential is that they agree kind of sort of roughly what is going to be stored in the blockchain, and then from there develop an operational practice where everybody's reading and writing to the same database, distributed network and all the rest of that. And over time, you sort out any compatibility bugs basically by shared common practice. You wind up with a set of best practices for using the shared database, and what comes out of that is extremely low-cost organizational interconnection in a way that doesn't involve taking the information from an internal database, pulling it back out of the schemas, turning it into an exchange format, and then pushing it back up the other side again. The cost is that if your organization has both a kind of big lump in SQL database and is working on blockchains, you simply wind up having to continually crunch stuff in and out of the blockchain backwards and forwards to the SQL databases. And my intuition is that the first wave of adoption of these kind of technologies will wind up with large monolithic product databases and then a layer of blockchain stuff on the front of that that is essentially used as if it was an API. The interesting thing at the side of this, however, is the possibility of blockchain native communication systems between businesses. So you have a set of businesses which want to do business together. They agree on a set of rough schemas to work together on a blockchain. They then implement the business processes directly on top of the blockchain. And as people are publishing and pulling from the same shared whiteboard, you simply build up this long history of what's happened, and you have a kind of convergence mechanism where you run a whole bunch of dry tests until the bugs are basically worked out. And after that, if something goes wrong, exactly what happened is documented on the blockchain, so you've got the ability to unwind it again. You don't wind up with 7 cascade failure type issues. So what I'm trying to flesh out here is the possibility that the sort of fuss about decentralized autonomous organizations is actually missing where I think the predominant organizational impact of blockchain technology will be, which is I think that it will finally enable networked organizations to function without having the colossal overhead of every organization in a networked organizational form carrying the load of its own database and then having to reify and de-reify information as it communicates with the outside world. Instead, you wind up with a rough standardization of what it is that's being done, right? We agree this is a disaster relief operation. We agree that this is something like Airbnb. We agree that this is something like Uber. You build some basic data types. You then read and write those in the community of people that are using it. And then over time, that can be evolved because you can always broadcast a note that you're going to be using a particular modification of the format when you're reading and writing from now on. And what you wind up with is companies and networks of companies which are interoperating at the data level without having this n-squared problem of everything has to communicate with everything else, and without creating the hub and spoke centralization, which is the traditional solution to the n-squared problem. So things like Visa typically operate by saying, right, we have the biggest database. You can all talk to each other by crunching your stuff down into our format and then exchanging it with the other guys in the system. And the problem with that as an approach is it creates these enormously powerful monolithic organizations who are powerful by their virtue of controlling a standard. Instead, the suggestion is that you can start a standard by having 3 people talking to each other. By the time that becomes 300, everybody has agreed what the database format is because it's the format we're using on that specific application inside of a blockchain. And what you wind up with is bottom-up standardization in the same way that you see, for example, in file formats. Everybody kind of agrees, this is what ASCII text will look like, this is how we use it, this is RTF, this is what it will look like. Or actually RTF isn't a good example. A better example would be restructured text. So bottom-up standardization efforts that result in the same kind of interoperability that you get with a hub and spoke operation like Visa, but instead very much broken down into a bottom-up standards process that gives database compatibility between all of the different actors involved without creating a monolithic core. And although that is quite a kind of slippery and philosophical concept, when you put that in terms of like seeing like a state, you begin to see that there's a possibility of changing the shape of society based on a shift in the underlying database technologies. Because if you have a society that is defined by standards rather than by centralized computing bodies, then the standardization processes, because they're bottom-up, are inherently, if not democratic, at least participation-centric. And if you bring the cost of doing this kind of participation-centric cooperation down below the cost of having these silos and with a much lower political risk, the possibility is that you wind up with a much more fluid approach to business and governance because there's a data rail into which you can plug, whether you're a small actor or a large actor, without having these catastrophic additional costs of having to build and maintain your own databases and then build your connectors. So what I'm suggesting is that there's a democratization of the kind of capabilities that have typically lived only inside of large organizations coming, because it is looking increasingly likely that blockchains in the long run will provide a solution to the problem of organizational interoperation at the database level. That was quite a mouthful. I can't believe I did that in one take. Thank you very much. I hope that made some sense to you.